Welcome PreCalc to our change in notes here. I'm hoping that you can read these. I am working on notes now instead of on a smartboard. I get to use an iPad and a stylus, so I'm going to apologize to start with for my handwriting and hope that it's legible and hope that you can make sense of this. This is actually 8.1 notes, which most of you were in class, and we did this the Thursday before we were put on shutdown. So most of you already have these, but I thought I'd redo them for those that were absent, or if you just want a quick refresher so you can watch me again as we start to work with matrices here in Chapter 8. So in 8.1, we're just starting with matrices, and the biggest thing different from Algebra 2 is we're working with an augmented matrix. So a matrix is that array of numbers involving in rows and columns. Each individual part in there is called an element. And we are going to work a lot this chapter with augmented matrices. So when we do an augmented matrix, it has the normal outside bars that look like this. And it is important to put those indents here on the sides because without them it stands for determinant, which we will catch at the end of the chapter. So make sure you're putting those bars on there. So on an augmented matrix, we start by taking the coefficients of each variable. So my x's are in the first column here, so 3, 1, and -2 coming off the 3 equations right here. And then next will be my y coefficients, -2, 3, and -5. And finally my z coefficients, which will be 5, -3, and 3. And in an augmented matrix now you'll see this vertical bar, and behind the vertical bar you will put your coefficients, or in this case these answers over here. So I have 31, -12, and 11, and that makes an augmented matrix. So a couple things here to remember. When you start a matrix, make sure all of your equations are in order with the same variable first, the same variable second, the same variable third, and so on. If so, the equal signs all in the same position, and your coefficients in the same, they're not coefficients, they're constants in the same position as well. If they're not, put them in those same positions first before you start to write your matrix. So let's move to the bottom of the page now with our matrix row operations. So one of the biggest uses of matrices is to solve systems of equations. So if you look at this matrix that they've started down here for us, you'll notice that it's a 4 by 5 matrix. So we have 4 rows. Those are our rows here, and we have 5 going this way because of the augmented. And so this would have been a 4 by 4 system of equations we're trying to solve. Now, we're not going to solve anything here. We just want to go through what we call a matrix row operation. So as you go through this, it should have some similarities to when we solve systems of equations in general. So I do want to kind of read some of these matrix row operations because they are important to note. So one of the things is 2 rows of a matrix can be interchanged, and this is just like interchanging 2 equations in a linear system. So that does come in helpful when we start our next page of notes and you see kind of the use. Sometimes you just want to move rows, so you just move them exactly like they look and you switch them. The second one says the elements in any row can be multiplied by a non-zero number. And this is just like when we multiplied a system of equations. We'd multiply one equation by 2 or -2 so that when we used it with another set of equation, it would eliminate. I do want to stress it needs to be multiplied. We can't add to a row. We can't subtract to a row. And it doesn't say divide. We technically can divide. We would normally think of it, instead of saying like divide by 2, we might say multiply by 1/2. So multiplication and division will turn into multiplication, are really the only things we can do. You can never add or subtract a row with a number because that is not a legal movement here. And the elements in any row can be multiplied by a non-zero number and then added to some other number or row like we would before. So this is kind of like our elimination method. So these are the legal moves, things we can do to change our matrices. 2 matrices are row equivalent if one can be obtained from the other by a sequence of row operations. All right, so we're going to try these row operations down here on example 2. They told us what they want us to do. And typically, just so you kind of understand the language here, when you see this operation here, it's going to go into row 3. This operation is going to go into row 4. So usually the row you see at the end is the one it's replacing. So we're actually leaving the top 2 rows the same. Let's hope I can actually write here. Small enough with my stylus. Okay, so on the third row, it tells us that we're going to do -2 times row 1 and add it to row 3. So if I took row 1 and multiplied by -2, I'd have -2, +2, -2, -2, and -6. If I take that and add it to row 3, so -2 plus 2 in row 3 makes 0. 2 plus 0 makes 2. -2 plus 3 makes 1. -2 plus 4 makes 2. And -6 plus 11 makes 5. Okay? And then the last row, it says I'm going to take that top row again, multiply by -5, and then add it to row 4. So I'm going to kind of write my work above. 1 times -5 is -5. -1 times -5 is 5. 1 times -5 is -5. 1 times -5 is -5. And 3 times -5 is -15. Now I'm going to add that to row 4. So -5 plus 5 is 0. 5 plus 1 is 6. -5 plus 2 is -3. -5 plus 4 is -1. And finally, -15 plus 6 is -9. And those are row operations and to change my rows. I still have what we would call equivalent rows, but we've just changed their value to do some work. I'm going to kind of show you this here just to highlight it. You'll notice in this first row, I now have 1 with zeros underneath it, which before I had other numbers. And as we go into our next page, you'll kind of see why I'm pointing that out, because that is kind of a goal we're going to work towards. So let's turn the page and try to see why we're doing these row operations. All right, so we are looking at a system of solving which is called the Gauss elimination method with back substitution. And I did give you this set of notes from the book, but one thing that we might notice as we do this is sometimes it makes more sense to see it done than to actually just read these notes. So we're going to start with writing an augmented matrix for the system. And then our goal here, as we look at this, is we want to get a 1 in the top left, and then we want to fill it with zeros underneath. Our next goal is to get in the second row, second number, I want a 1, and then I want to get a 0 underneath that. And finally, in the third column, third element there, I want to get a 1. So what's going to happen is we'd really like to have 1s in the diagonal with zeros underneath, okay? And that's our goal here, and then we can use it with back substitution, if that makes sense at all. So let me get back to my pen, and we're going to start here. One thing for sure is this can take up a lot of paper, so give yourself plenty of room. I'm going to do the best I can to write neatly, but definitely if you're handwriting it, that makes it a lot easier to do. I'm going to change to blue here. Okay, so first things first, we want our augmented matrix. So I'm going to start, and I just lost my pen here. All right, let me erase and try again here. I need to get rid of that thing. Okay, let's see if I can delete it. I don't know. Okay, let me start here. Okay, going down here. I have 1, -2, -1, and behind my vertical line is a 2. I have 2, -1, 1, and 4. I have -1, 1, -2, and -4. Now I can't stress enough, always double check to make sure your original matrix is written correctly, because if you make a mistake in the original, it will of course follow through in all your work and it will mess things up. So the more you can double check to make sure you have that written correctly to start with, the better off you're going to be. Okay, so remember our goal is to get a 1 in the top left and followed by zeros. I have my 1, but I need zeros underneath it. So I need to do some row operations to get where I'm going. So because I have my first row, I have everything good, I'm going to leave it just as is. So I'm going to leave it 1, -2, -1, and 2. But now in the second row, I would like to have a 0 there. Now there's multiple things I can do, but I'm going to stress if you are working with one row and you're working in that same column, so notice I'm working in the first row with the first column, I like to use, if I'm working in the first column, I like to use the first row to work in that column. So if I want to join row 1 with row 2 and get a 0, I'm going to multiply the first row by -2 and just add it to row 2. Okay, so -2 times row 1. Now, on the last page, I did write those numbers above it just for to try to keep myself so I don't write too much on here. I'm going to just do it kind of in my head, and hopefully you can follow. So I'm going to go to my first row, which is 1, -2, -1, and 2. I'm going to multiply that row by -2, each element, and then join it to the element, add it to the element right beneath it in row 2. So my first element is 1, times -2 is -2, add it to 2 beneath it, and I get 0, which is where I'm trying to go. But I have to do that all the way across, though. So my second element of -2 multiplied by -2 is +4, added to -1 gives me 3. My third element here times -2, so -1 times -2 is 2, plus 1 makes 3. And finally, in my constant column here, I have 2 times -2, which is -4, plus 4 is 0. And now when I go to do my last row, because I would like my last one over here to be 0 as well in the first column. Again, if I want work in first column, I'd like to work with my first row. So if I look at my first row compared to my last row, it looks like if I just add them together, I can get a 0. So I'm going to just do row 1 plus row 3. Row 1 plus row 3, so 1 plus -1 is 0. -2 plus 1 is -1. -1 plus -2 is -3. And 2 plus -4 is -2. So if you notice here, I now have part of my first goal with a 1 in the first column and zeros beneath it, which is something I want to do. And just a hint, I'd like to preserve those. I don't want to change those if I can help that. I want those to stay the same if I can do that. All right. So now let's go, and our next goal is to try to get this middle number here into a 1. So remember, there's two things I can do. I can add rows together, or I can multiply row and add it together, or I can just multiply a single row. When I look at this row I have right now, I have a 0, 3, 3, and 0. Well, if I divide by 3, or we could call it multiply by 1/3, I could get that middle 3 into a 1, and I really don't cause any trouble with my numbers. I will still have whole numbers. So I think that's what I'm going to do. I'm going to take 1/3 of row 2. Now, just a note, I like my row 1. I really hope I don't change it the rest of the time, because for this system on Gauss elimination, it's right where I want it to be. The 1's in the first column, and I don't care what's across in the next row. So I like that first one. Now if I take 1/3 of row 2, well, 1/3 of 0 is 0, 1/3 of 3 is 1, 1/3 of 3 is 1, and 1/3 of 0 is 0. And I'm going to right now just copy the next row as is. Okay, so as you can see, so far I have my first goal all done, and I have a 1 here. So my next thing I want to do is try to get a 0 underneath that 1. So just as a hint again, if I'm working the second column, the second row is the best row to work with to get zeros in that second column. So if I look at my second row and I look at my third row, if I need a 0 in that second position, the best thing to do is just to add my rows together. So once again, I'm going to leave my first row the same. And I'm going to leave my second row the same because I really like where it's at. And I'm going to go ahead and just add row 2 plus row 3. So 0 plus 0 is 0. 1 plus -1 is 0. 1 plus -3 is -2. And 0 plus -2 is -2. And I now have my goal of 1 plus zeros here. In the second column, I have in the second position 1 with a 0 beneath it, and now I have one job left, and that's to get a 1 in my third row, third position. And the best way to get that -2 to turn into a 1 is to divide by -2 or multiply by -1/2. So I'm going to see if I can do this in a really small position. I'm only working row 3. Row 1 I'm leaving the same. Row 2, I'm leaving the same. And I'm multiplying everything in the bottom row by -1/2. You can also just think of it as divide by -2. So 0 times -1/2, 0. 0 times -1/2, 0. -2 times -1/2, +1. -2 times -1/2 is +1 as well. So you'll notice I met my goal of 1 with zeros beneath it, 1 with a 0 beneath it, and a 1. So my diagonal here is all 1s with zeros beneath it. So we have done what we call Gauss elimination. Now we're going to back substitute to solve for our variables. If you remember, we made our augmented matrices by putting all the coefficients of x in the first column, y in the second column, and z in the third column, and then with our constants. So I'm going to start with this bottom row and change the little color here so we can see what I'm doing here. This means I have 0 x's, 0 y's. I have 1 z, and it equals 1. I know what z equals. Now I'm ready for the second one. I'm going to kind of come over here so I have a little more room. On my second one, I have 1y plus 1z equals 0. Well, I already know z equals 1, so y plus 1 times 1 equals 0. So y is going to equal -1 when I get it by itself. So now I have two of my variables done. I have my z, I have my y, and I'm ready for my back substitution to get my x. So taking my top equation here, that means I have 1x minus 2y's minus 1z equals 2. And I'm going to back substitute my z and my y that I already know. So x minus 2 times, excuse me, -1 minus 1 times 1 equals 2. So that gives me an x plus 2 minus 1 equals 2. X plus 1 equals 2, and x equals 1. And I've solved my matrix, or my system of equations with my matrix, and it looks like my solution set here is 1, -1, and 1. And there is my ordered triple that will answer this system of equations. So that was Gauss elimination with back substitution. Excuse me. Let's move on to our last page of notes for today. And this one we're going to add just a little bit called the Gauss-Jordan elimination method. So it's slightly different. And you'll notice here in the notes, we're still looking for our diagonal of 1s. And we still get our zeros like we had before. But you'll notice here too, we're going to add the zeros above it as well. So just a quick note here, what we're going to do. See if I can squeeze this note in here. We're going to work column 1 first. So first thing first, we're going to do column 1. And we want a 1 with zeros beneath. Then we're going to do column 2. 1 in the second with 0 beneath. Then we're going to get column 3. Oops, can't spell. 1 in the third. And now notice this with zeros above. And going to get second column, 0 above the 1. So that's kind of the order in what we're going to do this. So it's going to be similar to what we did on our last one, but we're going to work on zeros above as well. All right, so let me get my pen ready here, get a color going. And we're going to set up first our augmented matrix. So I'm going to start with 2, 1, 2 with 18 behind it. I'm going to have 1, -1, 2 with 9 behind it. And 1, 2, -1, and 6 behind it. So there's my augmented matrix to start with. And remember, our goal is to get 1 in the top left corner up on the column 1 with zeros beneath it and go from there. So One of the hardest things to do with matrices is to make your choice and make your decision how you're going to get your ones and your zeros. You can follow along with me and you'll be like, oh yeah, that makes sense. But I will tell you it's super important that you practice this, because there is, I don't want to say an art, but the more practice you do, the easier you will be at kind of finding the cleaner numbers and finding what to do. By the way, there are times you will get fractions or decimals in there, and that's okay. It can still get you the correct answer. But I know if you're like me, I like to avoid decimals and fractions as much as possible. So just a hint, I want a 1 in the top left corner. Some people would start to look at this and say, oh, take that top equation, divide by 2. You can do that. It will give you a decimal there in the center. But another thing, don't forget, you're allowed to switch rows. So my choice is just, I'm going to switch row 1 with row 2. And that's all I'm going to do is I'm just going to switch them. So I'm going to do 1, -1, 2, and 9 on top, and 2, 1, 2 on the bottom, or in the middle with the 18, and then I'll leave my third row the same for right now. All right, we're going to keep going here. So first thing first, I have my 1 on top. I want zeros beneath it. Remember, whatever column you're working with, it's best to work with that row with the other rows to go. So since I'm working with the first column, I really want to use row 1 to work to get my zeros in my other rows. So I'm going to, I want a 0 right beneath it on row 2, so I'm going to take -2, whoop, don't know what I'm on, -2 row 1, and add it to row 2. And remember, my first row right now, I'm going to leave just as is. I'm not worried about getting zeros in it till the very end. So everything in row 1, I'm going to multiply by -2. So my first element is 1 times -2 is -2. Add it to the 2 beneath it, and I get a 0. On my second column here, -1 times -2 is +2. Add it to 1, and I get 3. In my third column, 2 times -2 is -4, plus 2 is -2. And with my constants, 9 times -2 is -18. Added to 18 is 0. Kind of nice, it made that smaller. All right, and to save my paper space, I'm going to work on that third row at the same time before here. And if I look at my first and my third rows, I have a 1 and a 1. So it looks like I just need to do a little subtraction, or it's easier maybe to say negative row 1 plus row 3 to get my third row. So if I do opposite of the top, so -1 plus 1, I get 0. -1 with a negative makes it +1 plus 2 makes it 3. Row 2 here, or I'm sorry, column 3 here, I have 2 times -1 is -2 plus -1 makes -3. And on the constants, -9 plus 6 makes -3. All right, so my first goal here is good. I have 1 with zeros beneath it. So I like that column, and I'm hoping that that stays that way and I don't change that back. All right, so now I need a 1 in the second row, in the second position. And when I look at my current second row right now, I have a 3 and a -2 and then some zeros. So if I want to make that middle number a 1, I can divide by 3. But -2 divided by 3 is not a pretty number to work with, and I'll tell you right now, please do not turn that into a decimal, because you'd have to round and it will make things a messy later on. So I actually think if I look at row 3 and I see a 3, -3, -3, and a 0, that looks like the better row to divide by -1, or to divide by 3, but it's not in the right position. So if you can follow me here, I'm actually going to do 1/3 of row 3, and I'm going to switch it with row 2. Okay, remember row 1 I like. I'm not moving it anywhere. I'm going to leave it that way for right now. I'm actually going to take this third row and divide all of these by 3 and then move it to the second row. So 0 divided by 3 is 0. Or I can say times 1/3. 3 divided by 3, or 3 times 1/3 is 1. -3 times 1/3 is -1. And -3 times 1/3 is -1. And I'm switching it out with my second row. So my second row of 0, 3, -2, and 0 are just coming to the bottom. All right, so now on my second column, I really need that 3 on the bottom in the third row to turn to a 0. So once again, I'm not going to change anything in the first row. And to be honest, right now I don't want to change anything in the second row. But in the third row, I do need that to turn to a 0 right there. So again, if I'm working on the second column, it's best to work with the second row to get that the intended result. So in my second row, if I can multiply that second element by -3 and add it to my third row, I can get a 0. So I'm going to do -3 times row 2 and add it to row 3 to get my 0 I need. So in the second row, my first element is 0 times -3 is 0 plus 0 is still 0. In the second column, -3 times 1 is -3 plus 3 is 0. In my third column, -1 times -3 is +3 times, or add to -2 and I get 1. And then -1 times -3 is 3 plus 0 is 3. All right, so you'll notice I have my first columns exactly where I want it. Now my second column's where I want it. And as luck would have it, I have part of my third column right here with this 1. So I actually don't have to do that step as far as turning that into a 1 because it just inadvertently is a 1. But now let's take it, and we're not done. This would be done if we were doing Gauss elimination with back substitution, but we're doing Gauss-Jordan, so we're going to keep going now. So my next goal is to get my numbers above in my third column to turn into zeros. So just so you know, I'm going to kind of come up here with my work so you know where I'm going here. And just so you know, I now love my bottom row. It's not going anywhere. So I'm going to copy that one over. But now, because I'm working with, and I'm trying to turn these into zeros, I'm going to start working with my second row and my first row to turn those into zeros. And once again, I'm going to stress to you, whatever column you're trying to change, you want to work with that row of the same number. So I'm trying to change my third column, so I'm going to work with my third row to get the zeros where I want them. So when I look between row 3 and row 2, it looks like in that third column, if I just add my 1 and my -1, I can get a 0. So I'm going to do simply that. I'm just going to do row 2 plus row 3. Now, I'm kind of breaking a little rule here. Usually, maybe I should have put row 3 plus row 2 to make sure you knew I was changing row 2. So it really doesn't matter how you write that. I'm writing there so you can see it. And I actually would prefer that when you write yours, you also tell me that. So when I'm checking your matrices, I know what your intention was with that row. So I'm just adding my two bottom rows. In the first column, 0 plus 0 is 0. In the second, 0 plus 1 is 1. In the third column, 1 plus -1 is 0. And in the constants, 3 plus -1 is 2. And while we're at it, and to save space, I'm going to try to get that 0 in the top row as well. Now remember, I'm working in the third column, so the best thing to do is use the third row to work with the third column so that I can get that number I want in that third column. So if I look at my third row of 1 down there, and I want to use it with the 2 to get a 0, it looks like the best thing to do is to multiply the row 3 by -2 and then add it to row 1. So on the bottom, 0 times -2 is 0, plus 1 is 1. 0 times -2 is 0, plus -1 is -1. 1 times -2 is -2, plus the 2 makes 0. And 3 times -2 is -6, plus 9 is 3. All right, so once again, you'll notice I got my goal of 1 plus zeros. I got my goal of 1 with a 0 underneath. And now I have a 1 in the third column with zeros above. I have one last job, and that is to try to get this number right here to turn into a 0. And then I will have performed the full Gauss-Jordan elimination. So notice that -1 I would like to turn into a 0 is in my second column. So if I want to change a number in my second column, I'd really like to use my second row to change that. So when I look in my second row and say, what could I do to this element here to make this element here a 0, it looks like I can just add them together. I'm going to try to write this a little better this time. By the way, I love my bottom row, not changing it, so I'm just going to copy it over. I like my second row just as it is, so I'm going to copy it over. But last and final one now, here I'm going to add row 2 to row 1 to try to get that 0. So 0 plus 1 is 1, 1 plus negative 1 is 0, 0 plus 0 is 0, and 2 plus 3 is 5. So you'll notice I now have what I was looking for, 1 with a 0 beneath it, 1 with zeros beneath it, the 1, then I got the zeros above it, and finally I got my last and final 0. So you'll notice the 1's in the diagonal, zeros in everywhere else, and we are ready to go ahead and find the solution. Because this is my x column and there's only 1, my x, there's no y, no z, I just know x equals 5. In my second row, I have no x's, I have a y, I have no z's, and so y has to equal 2. And finally on the bottom, I have no x's, no y's, so z has to equal 3. So if you do this full Gauss-Jordan, you'll notice that it just gives you the answers fully once you have the zeros in the right spot. So my ordered triple would be 5, 2, 3. Now, it takes more work. Sometimes it's kind of a choice on, do you want to use Gauss with back substitution, or do you like to use Gauss-Jordan and get all the zeros? In many ways, it's your choice, but I do want to make sure you're aware of the methods and you can practice those. So if you are practicing them, and of course I did not, yes I did write it down, you can practice again on page 814 and 3 through 42's 3 through 42 by 3's, how's that sound? Would be good practice on that one. And again, I can't stress enough, it is important to try to do some practice on your own, because you can watch what I'm doing and say, yeah, that makes sense. But when you have to choose your own, it does become a little more difficult till you're used to what you're doing. So give it some practice, and we will continue with more matrices work in the rest of this chapter.